So Unit 2 is about polynomials. It's about multiplying polynomials and factoring. Multiplying and factoring. Primarily all around something called the distributive property. And there are some smaller components like adding, which we're going to do really quickly, and solving, which is a little bit bigger component that we're going to look at. And those will follow us throughout each section here. So we're going to start most basic right now and really look at the distributive property and what it is, and then we're going to expand upon it in future lessons. First of all, combining like terms. Combining, we're meaning adding or subtracting like terms. And just as we did with square roots, we do here. So x squared plus x squared, you have some background with. What would the answer be? 2x squared. So guys, when you add, you never change exponents. When you add, you're not adding really the x squared and the x squared, you're adding the coefficients in front, the 1 plus the 1, which gives us 2x squared. So it's like I have 1x squared and I have another x squared, so together I have 2x squared. Okay? So on number 2, same idea. We have parentheses here. If you have a plus sign between parentheses, this is the same problem as if you dropped all the parentheses. So this is, I could just do this, 2x squared minus 4x 6 plus x squared 5x minus 3. So those parentheses are unnecessary. It's okay to put them there, but they don't have to be there. Now on 3, it's different. Those parentheses do matter. Really, the second set does, because there's a negative sign in front of it, and that negative sign is going to have to be distributed to everything in there. But the plus sign doesn't matter so much. And here we look for like terms. So I got a 2x squared and an x squared. If I add those together, I get 3x squared. If I have a negative 4x and a positive 5x together, those add up to 1x. And I usually don't write the 1. And then if I have a positive 6 and a negative 3, add those together and you get positive 3. And that's as much as we can do. We cannot add the 3x squared with the x because they have different powers. We have x squared here, we have x squared. Okay. On number 3, similar thing, except we have to distribute this negative to all parts inside the second parenthesis before we combine like terms. And that's important to pause and just realize, because a common mistake is to do this, right? 2x squared minus 4x plus 6 minus x squared plus 5x minus 3. Where this is wrong, where you're only putting the negative in front of the x squared, it's not being distributed to the other two terms, and you'll end up with the wrong answer. So instead, it should be I'm going to fix that last part. Should be minus 5x and positive 3. Switch the signs. And then you're adding like terms as before. So 2x squared and a negative x squared gives us x squared. Negative 4x and negative 5x gives us negative 9x. And 6 and 3 give us 9. All right. So we'll use that combining like terms as we're working through these problems. Now the distributive property, again, you probably use this. We just did it with the negative sign. We distributed that negative. And so the distributive property here is a way to interact between multiplication and addition. And it's just a rule that says, hey, if you have multiplication with some addition here, you can multiply a times b and a times c. And I typically put it alphabetically. So ab plus ac. And that would, as much as I can do. I can't go any further than that. That's multiplying using the distributive property. On 5, if I multiply 2x times x squared, what do I get? 2x to the third. 2x times 4x. You multiply the 2 and the 4 and get 8. You multiply x times x and get x squared. And 2x times negative 2, negative 4x. So when you multiply, that's when exponents change. When you add or subtract, not so much. It's not going to change at all. But when you multiply or divide, then the exponents start to change. Okay. You can do this same property in reverse order. It's still the distributive property, but we now, the opposite of multiplying, not division, but factoring. And when you're factoring like something like number 6, you're looking at x squared and 5x, and you're asking, what can I divide both of those by? What do they both have in common? An x. So I'm going to factor out an x, I put that in front, and I divide each piece by x. So x squared divided by x would be x, minus 5x divided by x would be 5. And you can always check to see if you did it right by multiplying it out. X times x is x squared, x times negative 5, negative 5x. You know you did it right by going backwards. Number 9, what can we factor out? An x squared, what? A 3x squared, a 9x squared, a 9x. So you have options, but when we factor out the greatest common factor. What is the most, we want to be greedy here, what is the most we can divide both those by? So first you think about number, 9 and 36, I could divide them both by 9, and I can't do any better than that. And then how many x's can I pull out? 2 from both of those. So 9x squared would be the greatest common factor. And if I divide the first part by 9x squared, what do I get? X, because you're trying to think 9x times what equals 9x cubed, x, plus, if I divide 36x squared by 9x squared, I get 4. And again, you can check this by multiplying it out and seeing if you end up with that answer. You can do this with 3 terms instead of 2 terms. So take a look at these 3 terms. Decide what the greatest common factor is. Factor it out and see if you can get the right answer. Okay, what is the greatest common factor? What can you divide 28, 35, and 14 by? 7 goes into all of those. Can we do better? Okay, no, not better with numbers, but okay, now we got, how many x's can we divide out of all of them? Yeah, you're limited to the lowest one here, right? You can't go above the lowest. How many y's can we pull out of all of them? 2. Okay, so 7x y squared. And so if I divide each of these by 7xy squared, if I were to do that division, I'd end up with 3 terms. And the first one would be 4x to the third y. The second one would be 5y minus 2x. Okay. And then we've used the distributive property in the reverse order, which we call factoring. But the distributive property works both ways. Okay. Now, multiplying binomials. You may have done this before. I'm going to ask you to do it a different way, probably. Okay? because I want you to do it in a way that makes sense with what we've been doing. So we've been talking about the distributive property. And when you multiply binomials, yes, there are shortcuts, but my rule is you always have to understand the why before you take a shortcut, okay? And I take shortcuts, I do. But right now, we're not taking a shortcut, okay? So just as if we look back at number 4, I took the A and I multiplied it with the B and with the C. That's what I'm going to do here. Instead of taking one term, I'm going to take this whole thing and I'm going to distribute it to both pieces here. So it looks like this. That first piece here is an x. I'm going to multiply that x with the x plus 3 plus the second piece is the 1, and I'm going to multiply that with the x plus 3. Okay, so I need you to see where things are coming from. So this x right here, this plus sign's right here, and this 1 is right here. Okay, and so I'm just taking that x plus 3 and multiplying it with the x, and taking that x plus 3 and multiplying it with the 1. Just as we would with one term, you can distribute more than one term at a time. And then we keep distributing x times x times 3, 1 times x, 1 times 3. And then you always look at the end. If you can combine like terms, do it. So I have two terms that have just an x. So x squared plus 4x plus 3. So you may know how to do this another way, but I'm asking you to do it this way. So when you do homework, I want to see it this way. Okay, and there's a reason for it. When we get to factoring, you're going to see this done in the reverse order. Okay, number 10. Here's another common mistake, especially coming out of the last unit. Okay, I square that, and I square that, and x squared 2 squared is x squared plus 4. I've seen that a lot. That is wrong. Very wrong. What's wrong about that? It's tempting. Okay, this is a shortcut that we took there, right? Let's go. That's why shortcuts can be bad if we don't understand where shortcuts come from. What does it mean to square an item? It means to multiply it with itself. So this means x plus 2 times another x plus 2. Right? And that's what you're going to have to do there. Okay? And so then it looks like number 9. And so what we're going to do is we're going to take the first x plus 2 and multiply it with that first x, and it looks like this: x times x plus 2 plus, take the first x plus 2 and multiply it with the 2, and you get 2 times x plus 2. So work with the highlighter. This x plus 2 here is right here, and it's right here. It's been distributed for the other part. And then keep distributing x times x and x times 2. Two times x and 2 times 2. And we get x squared plus 4x plus 4, because what we're doing now is combining the middle two terms. And that's our answer. So try that with 11. Do it the way I've been modeling it. Use the distributive property a couple times to answer it. Not right now. But right now I want you to do it my way. Eventually I'll let you do that. Not yet. No, but I usually take this one and distribute both of these, so it's going to be x times x minus 6 times x minus 6. Okay, so in writing this out, you're going to distribute the x minus 6 to the x, and you write x times x minus 6, and then it's a plus sign here. I'm going to write plus sign, and then I'm going to distribute to the next one, and I get a 6 times another x minus 6. So the x minus 6 here has been distributed to the x, and it's been distributed to the 6. That's your first step. And then distribute more. X squared minus 6x plus 6x minus 36. Combine like terms. What happens to the middle term? If you have a negative 6 and a positive 6, that adds to 0. So this is x squared plus 0x minus 36. But really, what's 0 times x? 0, and so we really don't usually write that. But know this, it is helpful to know that x squared minus 36 is really the same thing as x squared minus 0x plus minus 36. That place value is 0. We just usually don't write it. Okay? But sometimes we will need to. All right, the last part here, we're just going to briefly talk about solving, and we'll keep bringing this theme up. But there's something called the zero product property. That zero product property, and it allows us to use factoring to help us solve difficult problems. And it's a simple property. It says this: if you have two unknowns, a and b, and you multiply them together, and you get an answer equal to 0, that's all you know. What can you tell me about a or b? Or what can you tell me at all? One of them has to be 0. Could they both be 0? Yes. Could they both not be 0? No. So one, either A or B, has to be 0. And either of them would make it work. Now, 0 is the only number that has this property. Let me show you. If I do this, A times B equals 3. Could you tell me what A and B are? What? But it has to be 1 or 3 or 3 or 1? Does it have to be? Can anybody give me another combination? Yeah? Okay, -3 and -1. Or -1 and -3. Can anybody give me another option? Yeah? 1.5 times 2. You see what's happening here? Once you bring in decimals and fractions, there's an infinite number of possibilities once you use a number other than 0. But 0 has to be 0. 0 is the only thing that has that property. And for us, if we're going to use this property, guess what the equation has to be equal to? 0. Because if the equation is not equal to 0, we can't use that property. So here's the idea. Here's our A, here's our B. A times B equals 0. So what does that mean? Well, that means either A is 0 or B is 0. And so x could be 0 here, or x could be -1. And now I have two possible answers for that problem. Okay? That's how you use that property. So on 13, we don't have the A times B setup here. We don't have a product of two things equal to 0, do we? But we can make a product of two things. How? By using the distributive property and factoring. What can I factor out of these? An x. And what's left? If I divide x squared by x, what do I get? X plus 5 equals 0. Now I have my form A times B equals 0. And so I could split up my factors and say, well, either A is going to be 0 or B is going to be 0. If A is 0, then this is x is 0. This one would be -5. And now I have two possible answers. And I can go back and I can plug them into the original. If I plug a -5 up here at the original, I get 25 minus 25 equals 0. If I plug a 0 in, I get 0 plus 0 equals 0. And both work. Okay. Was it? Zero product property on the Hidden Figures? I have to watch it again to see that. But yes, there's a lot of math in that movie. So your homework is like this. And let me show it to you again. So it's the next page, 1 through 24, 2.1. And I'm going to give you the rest of the time to get started on that.